Yeah, Ibrahim.
What, sir?
Ibrahim, audible. What kind of reaction is dehydration? Is it addition, substitution, elimination? Marwa, am I audible? Yeah. So what it is?
Substitution.
No, check it once more. What kind of reaction it is? Marwa, am I audible? What kind of reaction is dehydration of alcohol?
Yes, sir.
So tell me, is it addition, substitution, elimination? Check it and tell me quickly. What is happening? Just compare the starting and the final product. Right, Ibrahim? Just check the initial product and the final product, right? And see what has happened. Marwa, can you see what has happened in the reaction? Ibrahim, can you see the reaction? Acid catalyzed dehydration of alcohol. What it is? Elimination reaction. Got it? Why elimination? Ibrahim, tell me quickly. Any idea why it is elimination reaction, Ibrahim? Marwa, what is
Because we are removing the.
Yeah, it is because the water is getting eliminated, it is removed. Got it? You can check H and OH.
Yes.
Got it? So it is an elimination reaction. So just Ibrahim, can you explain me, Marwa, can you explain me just how it happens and what are the reagents? Very important reaction. Just tell me quickly how it happens. Ibrahim, can you tell me the quick mechanism? Just it is written in front of you, just you can quickly summarize it because it is a very, very, very important reaction. Got it?
The
How it happens? Yeah.
Yeah, so the unpaired electron from the OH will travel to the H plus ion. So we get a carbocation, basically.
Yeah. Yeah. The OH
With a
get
positive charge on the oxygen.
Hmm.
And then the electron from the bond will travel to the positive charge in the oxygen to neutralize it.
Yeah,
So that
water
will,
is removed, right?
yeah.
It
The
comes
second
out.
step is the removal.
OH comes out as water. This is a slow step leading to the formation of which reaction intermediate? Yes. It lead to the formation of a carbocation intermediate. Got it?
Yeah.
Right? And this carbocation, Marwa, is it going to stay like this always? Is it the final product?
No, sir.
No, because it is an intermediate. So what we need to do to get the final product? Tell me, Marwa, quickly. Just it is there in front of you. Just you can see it clearly. Just let me know. So once you have the carbocation, what happens? Which ion is removed in the next step? Tell me quickly. Ibrahim, can you see? Marwa, can you see? Which ion is removed after the formation of a cation?
H plus, H plus.
H plus is removed from the position adjacent to the cation. And you end up with an alkene. Got it? Is it clear? And how a carbocation, what will be the temperature? Because you are removing water. So for ethanol, it is 170. This temperature is very, very important. Remember it. Got it? So that's how it should happen. This is the mechanism. What is the rate of elimination? This elimination is known as even mechanism or rate of dehydration. Yeah, Ibrahim. Where it is going to happen most easily. It is going to happen most easily for the tertiary alcohol, then for the secondary, and then for the primary. Got it? Because
Yes.
the tertiary alcohol is can form a more stable cation. That is why it can undergo elimination very easily. Is it clear or not? Got it? So, Jasleen, just we were discussing the dehydration of alcohol. Okay. So just we will do one question and proceed to the next topic. It is very, very important, dehydration. Ibrahim, what I should take? Which acid should I take for dehydration? Tell you.
H2SO4.
H2SO, right? And Jaslene and Marwa, there were two alkenes. So OH is here. I can remove the H plus like this to get an alkene. Or I can remove the H plus from the ring. So tell me how it will happen. Aisha, am I audible? So this is the same reaction which happens with the concentrated H2SO4, but the alcohol is different. Just can you tell me one thing? Which alkene is formed in more quantity? Major product. Identify the alkene which is formed in larger amount. Identify the major product. I hope everybody understood my question. Aisha, Marwa, Jasleen, Ibrahim, all of you. Which alkene is the main alkene which is formed as a major product? Any idea? Which alkene is a major product? Who will tell me? Marwa, Ibrahim, Jasleen, Aisha. Which alkene is a major product? Which alkene is more stable? Tell me quickly. This is the new thing which we have not discussed in the previous class.
The second one.
The second one. Why? This is the major product, right? And this is the minor product. Got it? That is formed in a large quantity. Because if you try to look at the alkene, and the double bonds, right? It has three side. It is connected to alkyl groups on three side. You can see the carbon on atoms on three sides. Got it? Carbon atoms on three side. Methyl. So it is Is it clear what is written? All have the same meaning. Can you see what I have written? How to identify the main alkene, major product for the elimination reaction? Jasmine, can you see it? It should be more branched, more substituted, more alkylated. Got it? And this alkene has more hydrogen and less number of alkyl groups. Got it? So this alkene, which is more alkylated alkene, Jaslene, it is known as Sedzev alkene. So out of the two alkene, if the double bond is coming two sides, just look where you have more number of carbon atoms. Got it? Marwa, is it clear? Ibrahim?
Yes, sir.
Okay. You need to look where you have more carbon atoms on which alkene you have more alkyl group. So that is the main alkene. And the alkene which is less number of alkyl groups connected to the doubly bonded carbon, it is called less, the same, less branched or less substituted. This is known as Hoffman alkene. So always remember, this is there in the previous chapter also we have seen, and this is there in the dehydration of alcohols also. This alkene is going to form in the lesser amount. Marwa, is it clear? Aisha, is it clear? All of you?
Yes, sir.
So I hope everybody understood this, how to decide which alkene is going to form in the larger amount and which alkene is going to form in the lesser amount. Got it? So be careful about it. And always, so for all the, suppose if you are getting two alkene, different alkenes, so always check which is major and which is minor. Got it? Let me move to the next reaction. This is complete removal of OH and H, water. So it was basically dehydration of alcohol. Okay. Now we are going to discuss the oxidation of alcohol. So Ibrahim, what do you mean by oxidation?
Removal of electrons or addition of
Yes,
oxygen.
removal of electrons or more oxygen are being removal of hydrogen. That is also oxidation. Got it? And or addition of oxygen. So you have different definitions for oxidation. So suppose if you have an alcohol, got it? The first step for the oxidation is removal of hydrogen. And you end up with double bond oxygen, because you have removed two hydrogen atoms, so you have to form a double bond between the carbon and oxygen. Okay, this is oxidation of alcohols. Okay. The primary alcohols can be oxidized in two different steps. Can any one of you help me out how primary alcohol can be oxidized in two different ways, two different levels of oxidation for primary alcohol? Secondary alcohol is having two sides, you have an alkyl group. This is primary alcohol. Got it? This is secondary alcohol. It is a second. This is a primary carbon connected to one carbon. R is any alkyl group, Marwa. It could be methyl, ethyl, propyl, right? And Jasleen, this is secondary, and Aisha, tertiary is the one which has all three alkyl groups connected. Got it? This is the tertiary. Is it clear? I hope. Primary, secondary, tertiary, because what will be the product for oxidation? That depends upon the type of alcohol which you have taken. Is it clear or not?
Yes, sir.
So primary alcohol, if you use the mild oxidizing agent, you will end up with an aldehyde. You remove H and H. Got it? Mild oxidizing agent or weak oxidizing. Is it clear or not? Any doubts in this? If you take strong oxidizing agent, the primary alcohols get oxidized to carboxylic acid. Marwa, can you hear me?
Yes, sir.
So is it just say it once, what happens with when you oxidize primary alcohol? Just could you please repeat? If you oxidize primary alcohol, what can you get? What could be the different products?
Aldehyde and carboxylic acid.
Aldehyde, if when you get an aldehyde, yes, exactly. When you get an aldehyde. Yes. Justly. So aldehyde is obtained when you use mild oxidizing agent, weak oxidizing agent which is not very strong. Right. And carboxylic acid has more oxygen. Jasleen, Marwa, right? So because they have more oxygen, so if you take strong oxidizing agent, you will end up with carboxylic acid. Got it? What are the mild oxidizing agent? Can you tell me? Mild means weak. Okay. Mild oxidizing agent is PCC. What's the full form of PCC? Ibrahim, are you there?
Yes, sir.
So pyridinium chlorochromate, what it is used for?
It's a reducing agent here.
No, you have just told me an opposite answer, PCC. What are we doing?
Oh no, sorry. It's an oxidizing agent here.
It is an oxidizing agent, right? Yes. Got it? Oxidizing agent. So oxidizing agent, is it a strong oxidizing agent or a weak oxidizing agent? Aisha, can you tell me, is it a strong or a weak? Ibrahim, you can also continue. Is it a strong oxidizing or weak oxidizing agent?
It's strong oxidizing.
No, it is weak, right? Just it is a weak oxidizing agent. Got it? Is it clear or not? Weak oxidizing agent or mild? And because it is mild, the reaction is going to stop at aldehyde only. Is it clear? So Jaslin and Aisha, what is the formula for pyridinium chlorochromate? So you take CrO3. Okay, you take pyridine. This pyridine is like the benzene with one nitrogen, NHCl. Got it? So this is the formula. Either you can have that pyridinium chlorochromate. Is it clear or not? Right. So it is a mild oxidizing. Yeah. Aisha, what another mild oxidizing agent can we have? This is the formula for PCC. Okay. Or we can use copper red hot tube. Copper red hot tube, copper 300 degrees Celsius is also a mild oxidizing agent. Got it? And Ibrahim, when you will get carboxylic acid, tell me. When you will
Fe
get
is
the
strong. If
yeah,
Fe
if
is
it
strong
is,
oxidizing agent.
and with what type of alcohols you are going to get carboxylic acids?
Primary.
Primary with the strong means more oxygen. Okay. And aldehyde get oxidized to carboxylic acid. And strong oxidizing agent, Ibrahim, can you tell me some of the strong oxidizing agent which you may have done in your school practicals also? Two very strong oxidizing agent which you may have used in your school practicals. Also, in titrations, you may have used them. But in this case, we are using them for oxidizing alcohols. And they are brightly colored also. Two very strong oxidizing agents which are very brightly colored. Aisha, am I audible? Jaslin, Marwa. So you may have used them in your practicals school. practicals in titration?
Potassium.
Yeah, potassium.
Bromine.
Yeah, potassium permanganate. Got it? Is it clear or not? Right? Potassium permanganate is KMNO4. Okay, that is strong. Okay, I will write it here. Acidified potassium permanganate. Or you can use another very strong oxidizing agent that is also brightly colored. Potassium dichromate. Is it clear? Or anyone you can use. Is it clear or not? So primary alcohol, if you are using the KMNO4, okay, you are going to end up with carboxylic acid. K2Cr27, you are going to end up with carboxylic acid. Is it clear to everybody? Any doubts? Suppose if you take the secondary alcohol, there is only just one option. Ibrahim, can you tell me that option? What you are going to get with the secondary alcohol? Which functional group are we going to get?
Just ketone.
Yeah, ketone only. So whether you take KMNO4H plus, whether you take K2Cr27H plus, whether you take PCC, pyridinium chlorochromate, or you take copper 300 degrees. Copper red dot tube, all were oxidizing agent. The lower two were mild, the upper two were strong, but that mattered only in the case of primary alcohol. In secondary alcohol, we are just going to get, what are we going to get? Ketones. Jaslyn, is it clear? Got it? Is it clear or not? Any doubts on this? And what about tertiary alcohol? Jaslyn, tell me what about the tertiary alcohol? If you try to oxidize them and try to make a double bond, will you be able to do so? For tertiary alcohols, there are 3 carbon containing groups connected to the carbon carrying OH. Got it? Is there any H, Ibrahim, connected to the carbon bearing the OH?
No.
No. So how will I make the double bond? Will it be possible? It will not be possible. So what should I say? No oxidation. Is it clear or not? So tertiary alcohol do not get oxidized. Suppose if you heat them with copper 300 degrees, they will not get oxidized. Water will be removed, which is not an oxidation. You will get an alkene. Got it? Any doubts in the oxidation? You can use CrO3, PCC, copper, 300 degrees, right? Right? So let's do some questions for the conversion. Yeah, Ibrahim, are you there? So I am writing the steps. Got it? You need to tell me the reagent. So 4 reagent, all 4 of you will tell me, each one of you will tell me one reagent. Got it? So be ready for it. So all of you, are you present in the class?
Yes, sir.
Yes, sir.
Okay, great. So how we are going to get this? Who will tell me?
So bromine.
So the
Yeah,
HBr,
Rajesh?
HBr.
HBr? No. It's not HBr.
So Br2.
Yeah, Br2, and in the presence of
Any heat or light.
yeah, Br2, that is in the presence of light. Got it? Photohalogenation. I hope this is clear to all of you. So get ready for the next. Once you have the Br, how can I replace it with OH? Just tell me quickly. Marwa, can you recall how to remove the Br and put OH in place of Br? Marwa, am I audible? How to replace? This is a substitution reaction. SN2. Just try to recall quickly. Jasleen, you can help Marwa. Tell me.
So using a new
Using something which has OH. Yeah. So what should we take?
take a new
We can take some base, right? KOH. Is it clear or not? K plus and OH minus. Got it? Aqueous. Is it clear? Aqueous KOH. Then once you have this, okay, this is a substitution reaction. OH is coming in and Br is coming in. Then what you are going to get for this conversion, what reagent should we use? Tell me quickly, all of you know this is what? This is oxidation. Is it a mild or a strong? Ibrahim, tell me quickly. Is it a mild oxidation or is it a strong oxidation? You can see the number of OH, oxygen atoms.
It's mild. It's mild. I think.
Mild, no, not mild. More 2 oxygen are there, right? So it's a strong oxidation. Mild, you will get aldehyde only. Just one double bond. And if you take strong, you will end up with carboxylic acid. Is it clear? So this is strong oxidation. Ibrahim, Jesslyn, can you see? Is it a strong or mild? Are you convinced or not? Very, very important. In mild, just make double bond O, that's it. Okay. For primary alcohol, if you want to make a strong, if you want to do the strong oxidation, you need to make it carboxylic acid. Got it? So what reagent should I use, Jesslyn? Ibrahim? Marwa, tell me, what reagent shall we use here? Look here, just try to recall primary alcohols. The product were either aldehyde or carboxylic acid. So tell me quickly, what should we use? You know, yes, Jesslyn, exactly. You are going to use the two strong, very strong oxidizing agent which we use in lab. Either you can use acidified potassium permanganate or you can use acidified potassium dichromate. Ibrahim, what about this? Marwa, this is strong or mild? This one. More oxygen or just one oxygen? This one. Aldehyde. Aldehyde, there is one H still remaining, so it is not completely oxidized. So is it a mild oxidation or a strong oxidation of a primary alcohol? Yes, this is mild. Got it? Because aldehyde still has one hydrogen yet to be oxidized. Okay, that is still remaining. So we have not completely oxidized like we did it in the acid. So acid was strong. This is mild, weak oxidizing agent. Okay, and which is the weak oxidizing agent? Two very weak oxidizing agent we discussed today. One is abbreviated name PCC. Marwa, is it clear? One is PCC. Another one is copper red hot tube. Any one you can use. I'm putting or. Is it clear or not? Any doubts? Right? So this is the conversion roadmap. Ibrahim, this is very, very important because this conversion roadmap converts 4 chapters: alkanes, alkyl halides, alcohols, and aldehyde ketones and carboxylic acids. So very, very important. Got it? So let me ask another question. So I hope all of you are ready, all four of you are ready. You need to tell me the reagent. Got it? Yes. So the first option, what should be the answer? To the first option, quickly tell me. Yeah, Isha Marwa, tell me quickly. What should be the answer to the first question? What we have done? We have removed HBr, right? I hope all of you can see it. So once we have removed HBr, and that can be done by taking alcoholic KOH and heat, that is elimination reaction. Is it clear? Aqueous KOH substitute Br with OH, and alcoholic KOH is used to do the elimination. Once you have the elimination means HBr, removal of HBr, you have a double bond. Once you have the double bond, how can you add water? This is the first method which we have seen for the preparation of alcohol. Acid catalyzed hydration of alkenes. That is using dilute H2SO4. I hope all of you remember it. And this is the oxidation, because you have converted the OH to double bond O. Is it clear? So how we are going to do the oxidation? Jasleen, tell me quickly, should we use mild oxidizing agent or strong oxidizing agent? Or anyone can fulfill the purpose. Ibrahim, Jasleen, tell me quickly. Mild or strong? This is secondary alcohol. So you can use mild or strong, anyone, and both of them will work. Got it? Anyone you can take. Strong or mild, you are going to end up with ketone only. Ketone do not get oxidized easily, right? So you can either choose just in mild or strong. Either you can take KMNO4 or copper red hot tube. Both will fulfill the purpose. KMNO4, H plus and heat, which is represented by delta, or we can use copper 300 degrees Celsius. Is it clear or not? To all of you. Got it? So let's move to the next reaction. This is oxidation reaction, very, very important. Okay, and these two questions are very important for us. Okay. Primary alcohol, there were two options, aldehyde or carboxylic acid. With mild TCG, you ended up with aldehyde. Copper 300, you ended up with aldehyde. With strong, you ended up with directly with carboxylic acids. For ketone, there was only one. For secondary alcohol, there was just one option, ketone. And for tertiary alcohol, there was just one option, no oxidation. With copper, it undergoes dehydration. Got it? So this, I hope, is clear to everyone. Now let's move to the, so this was the oxidation of alcohol. Now let's move to the oxidation of the reactions of phenol, which may include oxidation and reduction. We have seen preparation of alcohols and preparation of phenols. Similarly, we have seen the reactions of alcohols and reactions of phenols. Okay, so we are going to move toward the chemical reactions and of phenol. Got it? So Ibrahim, are you there?
Oh, yes, sir.
So what type of reactions phenol will give? Any idea? Any idea if you are having? What kind of reaction should we consider for phenol? It is none other than the reaction given by the benzene. Got it? Because the phenol is having the benzene, that is the main part, right?
Yes.
So what all we can do on the benzene? Any idea?
Substitution, nucleophilic.
Yes, substitution we can do, and that substitution can be nitration, halogenation, sulfonation. That are the common reactions given by the benzene ring. Exactly. So substitution, let's say nitration. So Marwa, what do you mean by nitration? Suppose if I am telling you nitration means what group I am attaching to the benzene. Nitration means what? Am I audible? So what do you mean by nitration? Attachment of which group is called nitration? Attachment of NO2, right, is known as nitration. What you are going to take for NO2? Nitric acid. Is it clear? Dilute nitric acid are we going to take? And just look at it very carefully, because this is going to be useful for all your subsequent chapters and all your reactions, upcoming reactions of benzene ring. The oxygen has unshared pair of electrons, and they actually overlap with the benzene electrons of the benzene ring, and you have the lone pair moving into the benzene. This is resonance. Aisha, what is effect it is known as? What's the name of this effect?
Resonance.
Yeah, it is resonance, right? And this is plus R effect, plus R or plus M effect. By this, the lone pair of the benzene is the lone pair of the oxygen, not the benzene, is the lone pair of the OH is getting into the benzene ring. Is this clear? So where this lone pair can come in? Where else? Ibrahim, Marwa and Jesslyn, is it clear or not? Tell me. Jesslyn, are you getting what I'm trying to show? Before doing any reaction, I am first trying to look at how the benzene ring of the phenol behaves, where the electron density is, because that is the key to solve all the problems. If I am aware of the electron density of the benzene ring, I can easily figure out where to put the plus positively charged electrophile on the ring. Okay. So this is the resonance, and by the means of resonance, the OH group is giving the electrons, its unpaired electrons, to the benzene ring, and those unpaired electrons are being appearing on the ortho position. This is ortho. Para position, which is just opposite to the OH, and the other ortho position. So both the ortho position and the para position, which is just pointing downwards, that becomes more electron rich. Is it clear to everyone? Got it? Any doubts in this? Okay. So now, once we have this, now we can figure out where should we put the nitro group. Ibrahim, tell me what all products we can get by doing the nitration of phenol. Are we going to get ortho, para? Yes, Jasleen, correct. Ibrahim, you tell me ortho, beta or para?
Para.
Both.
Para,
can
I
get.
think. Yeah. No,
Ortho
both. You
also.
can get both. Yeah.
Because ortho
Yeah, we
also
can
has negative charge. Para also is having a negative charge, right? So both ortho and para nitrophenols you can get. So Jasleen, your answer is correct. Marwa, have you understood this? Aisha, any idea how to separate these two? Orthonitrophenol and paranitrophenol. How to separate ortho? This is a very famous question. Very, very important question. But very simple and very commonly used question. Any idea how to separate them? What method should be used to separate orthonitrophenol and paranitrophenol? Tell me quickly.
You're using steam something? Steam?
By?
Using steam? Or
Yes, steam distillation. Exactly. So orthonitrophenol has lower boiling point and it can be removed by steam. Okay. So it can be separated by steam distillation. I hope this is clear to all of you. But why it is having lower boiling point and why para is having higher boiling point? If you look at it closely, you will observe that this H and O minus of the nitro group are connected to each other by intramolecular. Within the molecule, the hydrogen bonding is taking place, intramolecular hydrogen bonding. And this molecule doesn't interact with other molecules. So it can come out very easily. By letting the steam to pass through the mixture, you can separate the orthonitrophenol. This is a very, very famous question. What about this one? Paranitrophenol. Is it easy to separate? No. It has got high boiling point. Because the OH and the NO2 are opposite. So they are not participating in hydrogen bonding. In fact, they are participating with the hydrogen bonding with the other molecule. That is called intermolecular. Molecular hydrogen bonding. Is it clear? And that will increase the boiling point. Okay. So this, I hope, is clear to all of you. Any doubts?
No, sir. No, sir.
But very, very important. And remember one thing, we have taken dilute. So dilute is a kind of mild substance. Okay. This diagram are given in your NCRT, right? Orthonitrophenol, paranitrophenol, very, very important, very common. Suppose if we go for the nitration of phenol with concentrated nitric acid, what are we going to get? Concentrated nitric acid means the NO2 ions are more in it. We have taken concentrated acid. Is it clear? So what are we going to get? What is the name of that compound? Tell me quickly.
The picric acid.
Oh, yes, Aisha. Very good. And that is trinitrophenol, picric acid. It is 2. This is the second carbon if you start from OH. 2, 4, and 6. Trinitrophenol. Its common name is Jasola. Its common name is picric acid. Got it? So this is the nitration of phenol. I hope all of you are comfortable with it. Okay. And next is halogenation of phenol. But always remember where the reactions are going to take place. And the root cause for the reaction is the electron richness of the ortho and para positions. Got it. Ortho-para positions are very highly electron rich. So those are the places where the electrophile is going to connect. Bromination. Bromination is also very famous, and one of the part is one of the method for bromination is used for the experimental determination of phenol. Bromination also can be done in two ways. One is by taking bromine in carbon disulfide, which is a non-polar solvent. Ibrahim, what do you mean by non-polar solvent? Can you tell
Something which doesn't have a dipole moment in it.
which
Like-
doesn't have dipole moment, right?
Yeah.
Non-polar. Polar is having a dipole moment. Okay. And you are going to choose ortho and para positions for the reaction only. The reason already we have written in the above reaction. So either you can put the bromine on the ortho position or on the para position. But there is a difference in the reaction when you do the same bromination in the presence of water. Water is what kind of solvent? Is it a polar solvent or a non-polar solvent?
Polar.
It is polar, and we know that salt, common salt which we use in our home, Na plus and Cl minus, it gets dissolved, it splits into water. Okay, water can dissolve many ions, that all of us know. And many molecules split into ions in water because water being polar. Okay, and if you take the water, aqueous medium, as the solvent, you observe a very different thing in this. The Br get attached on all the three positions of the phenol. All the three positions. Will be substituted, H will be substituted by Br, and this is known as 2,4,6 tribromophenol. Just like the picric acid, where you had 3 nitro group. In this case, we are having the 3 bromine group. This is white PPT. And also used as a test for phenol. Got it? So why it happens in water? Any idea? Ibrahim, tell me. Any updates? Why this has happened? Why the 3 bromine have attached themselves to the benzene or the phenol? Aisha? Jasleen? What could be the reason? behind it. The reason indirectly it is written. It is a polar solvent. So what happens in the polar solvent? That you need to explain it to me. Ibrahim, Aisha, Jasleen, Marwa, tell me quickly what happened. Am I audible to everyone? So why you end up with the bromine getting attached? Ibrahim, tell me quickly. What's the reason? With water, what happened? It is a polar solvent. So polar solvent, what it will do? It will ionize the phenol. Remember that we discussed that the phenol is a weak acid and it loses its H plus and it becomes a phenoxide ion. And the phenoxide ion is more electron rich. It has more electron density. Is it clear or not? Got it? It is more electron rich, more electron density at the ortho and para position as compared to the neutral phenol. There you had OH and here you have O minus. So more negative charge means more reactive. Is it clear to all of you? Ibrahim, Jasleen, Marwa, tell me quickly. Okay, be clear in this. This is a very important question. So what is the test for phenol? One of the tests is when you take the bromine water, you end up with a white colored PPT. Is it clear? Of tribromophenol, 2,4,6 tribromophenol. Okay, 3 bromine groups are going to come and join themselves to ortho and para position. Clear? This is nitration, just like nitration. There, but in nitration, you need to take the concentrated nitric acid. Okay. So let's do some problems. So you have to do the nitration of phenol. You need to write the mononitration products. Ibrahim, what do you mean by mononitration products?
So like when we add one nitrogen, one nitro
One
group, so
NO2 group, right? So what all possibilities can we have? And suppose if I ask you to write dinitration product, where we are going to add the NO2 group. That is already clear from the previous example. We have seen the nitro group is going to come at the ortho and para position. Got it? Is it clear or not? So if you are just attaching a mononitro product, you can attach it, but don't attach here. What's the reason? Jaslin, Marwa, why should I not attach the NO2 group in the middle on the ortho position which I have indicated? What's the reason? Jaslin, what's the reason? Why I put a cross on that ortho position? Though that is also ortho. It's because in the middle, yeah, the compound, yeah, in stable, it becomes too crowded. If you attach the NO2 group in the middle of the two, so I will choose either of the positions which are outside ortho and para position, but not the ortho position which is in the middle of the two groups. Okay, so remember this, very important. Either we are going to choose this, or we are going to choose the lower position, but not the ortho position which is there in the middle. Got it? Dinitration product. So dinitration, again you are going to put the two nitro group at the two positions. But not in the middle. That's because that middle position is too crowded. It is surrounded by two different sides. Got it? So this is going to be the product. Clear? Ibrahim, this reaction I already told you in the previous class. Can you just try to recall it for me what it was? Something related to the preparation of some medicine also we have discussed.
Yes, it will form aspirin, yeah.
This is attachment of COCH3 and removal of HCl, right? We have seen this preparation of aspirin. Got it? So this is the same reaction. So what are we going to get? Marwa, is it clear? In the aspirin also we were doing this. This is acetylation, right? Got it? Suppose if I do the nitration and take the para isomer, I am writing the product. You are either going to get ortho or para, but ortho is going to be a bit less because this group is big group and it is going to prevent the attachment of NO2 at the ortho position. So the NO2 is going to join itself to the para position. But what is going to happen if I forcefully now bring in the next NO2 group. Okay, that may get attached to the ortho group. Is it clear? Got it? Any doubts in this? So first one, I'm going to choose the para with a bigger group. And now I'm going to choose the ortho. Okay. So this, I hope, is clear to all of you. Next, very important reaction, which is used for the preparation of aspirin, we have seen, right? So how aspirin was made, could you quickly recall? Ibrahim, can you quickly recall how the aspirin was made? Any idea? What was the starting material?
Salicylic acid.
Which acid?
Salicylic acid, yeah.
Salicylic acid, right? Exactly. So how to prepare salicylic acid was having one COH and one OH group. Got it? So actually, how to prepare that salicylic acid from phenol? So I'm writing preparation of salicylic acid. Got it? Salicylic acid, just we need to put COH group. So, Jaslyn, how we are going to put the COH group? Salicylic acid, Aisha, how we are going to put? First
So
take NaOH. Yeah, tell me.
what's the question?
Pardon? Your voice is very low. By taking something around us which is having the COO around us everywhere, that is CO2, right? So yes, we are going to take the CO2. Is it clear? So CO2 is actually going to react. So this is carboxylation of phenol in the present. NaOH we took because you need to make it more reactive by making it O minus. Okay. This reaction is known as Colby's reaction. So always reaction, actually it is the carboxylation. So remember we had a minus charge because of the resonance. So that minus charge is going to get connected to CO2. And you will have a CO2 group connected to, because the minus charge was there, so then now this will become CO minus. Right? And you take upon acidification, it becomes OH. And COH. Got it? Is it clear to everyone? So this is the preparation of salicylic acid. So Ibrahim, can you just quickly recap how to convert the phenol to salicylic acid? What reagent should we use? Yeah, tell me.
The NaOH and that's and
CO2. CO2. This is CO2, right?
yeah, CO2, CO2 and
And
H plus.
this minus charge is there. This CO2 will get attached to CO2. Got it? So this CO2 now it will get attached as CO minus on this. Ortho position is more reactive. There are two ortho positions, so you are going to get the ortho substituted product more than the para one. This is salicylic acid. Okay. So suppose if I ask Aisha, Jaslin, if I ask both of you how to starting from phenol, can we prepare aspirin? This is a common question asked every time. Okay. Starting from phenol, can we get aspirin? Okay. So aspirin directly we cannot get. First, you need to convert the phenol to salicylic acid. By reacting with NaOH, CO2, followed by acidification with H plus. Got it? So you will have the COOH, right? Salicylic acid. Once you have the salicylic acid, you can do the esterification of alcohol or acetylation by taking CH3COCl or acetic anhydride. Any one you can take. Got it? So your OH is going to get converted to OCOCH3. And I also asked you what is the IUPAC name of this. That is to acetyloxy benzoic acid. That's the name for the phenol. Is it clear? Any doubts on this? Preparation of aspirin from phenol. This is a common question being asked in boards. what this process is known as? Ibrahim, tell me this process and what is the name of this process? Ibrahim, are you there?
Yes, sir. It's called acetylation, I think. Yeah.
Yeah, first one is the carboxylation.
Oh, okay. Yeah.
And-
The first one is carboxylation.
And
Second one is
the
acetylation.
one is acetylation, right, of the OH group that happens for the alcohol, right? And what are the acetylating agents? CH3COCl, right? Acetyl chloride or acetic anhydride. The second one is anhydride, right? CH3CO, OCOCs, right? So this is very, very important reaction. Next class, we are going to start with much more important reaction related, similar reaction, but still different, and some similarities and some differences are there. And that is preparation of the aldehyde, similar with the similar structure, that is salicylaldehyde. There's a salicylic acid, okay, salicylaldehyde, a parallel reaction, very, very important name reaction for the phenol. Okay. So let's discuss it, the next reaction in the next class. Okay, so let me in today's class. Okay, guys, bye bye, everyone. Good night, take care. Just go through our NCRT in-text problems, right, and the back exercise. That is very, very important. Okay, and do let me know in the next class if there is any problem. Right. Okay, so let me in today's class. Bye bye, take care. Good night.